All right, back in action. We are looking at page 198. This is still 7E part 2. I want to do the volume of C and F. I've chosen a shape which is made up of rectangular prisms and then something with curved surfaces in it. So we've got a cone on top of half a sphere or a hemisphere. Right. Now there's optionality as to how you break up this shape, but you will need to break it up into different shapes. We could imagine this as 3 rectangles. If I put lines down here, I could find the area of this part, A, this little bit in here, and this other end, which is the same. So A and C have the same dimensions. Now, would that work? Just pondering over this, we've got that middle bit there, right, is 3 centimetres long, 3 centimetres, and that height there would have to be 4. Okay, so that's probably how I would do it. So yes, that method would work. An interesting way to work out the volume of this shape might be to imagine one larger rectangular prism without that little hole cut out of it. So something your instinct might be to do it that way. I could see that that dimension there, let's call it a length, would be 2 plus 2 plus 3 is 7. The height here is 10. And the depth of this shape is 3. So I could do 3 times 7 times 10, that'll be 210, and then I could subtract away the little rectangle from here. So I could say minus this little rectangle, that's been cut out of that shape there, and that had dimensions 3, 3, and it was 6 high. I haven't drawn it very well. You'll notice that a lot of these things are not drawn to scale exactly, right? So I could subtract that away, and that will work fine. But I think I want to do this in 3 parts, and imagine cutting this shape, and well, there's another way you could do. You could cut these rectangles, A and B, off the top, find their volumes, and add that to this rectangular prism on the bottom, and add it all up. So I'm going to use an A plus B plus C method, but I think I'll just go with what my first instinct was to cut the shape up lengthways, right? Let's call that A, and maybe we'll call this B, because A and B are the same, right? And then we'll have to work out what this little shape in the middle is, what its volume is, right? So the first 2 rectangular prisms that I've got, and don't be afraid to do little sketches like I'm doing. Actually, that one's so bad, I'm going to do it again, sorry. It'd be a little bit easier on grid paper with a real pen. So I'm drawing out what shape A and C is. This is A and also C. No, sorry, I called it B. A and B. Okay, it was 2 centimetres across the back. All right, see those 2s? It's 10 centimetres tall, height of 10. Let's call that maybe a width or a length of 2. And this depth here, which you could also call a width, is 3. All right. So what's the volume of that? So the volume of A would be 3 times 2 times 10. Right? It's the area of the top times the length, or you could look up a formula that said length times width times height, or something similar to that. So 2 times 3 is 6 times 10 is 60. These are in centimetres cubed. All right, the volume of both A and B would have to be 120 because there's 2 rectangular prisms that are the same. All right, now what about this little bit in the middle here, this C? I'm going to draw it over here. So I've got a smaller rectangular prism in the middle. We're calling it C. In the middle here. Well, I can see clearly that there's a 3 across the top there. Right, so that side is 3 centimetres. Over here, I can see the depth or the width of that shape is also 3. But what about the height? They don't actually tell me what's the, well, they don't say directly, what's that distance there? But if I know that the whole shape is 10 and that we've lost 6, so what are we left with here? And the answer would be 4. All right. So we've got a 3 by 3 on the top. Right, that 3 could also be put up there. So we have 3 by 3 on the top, which is a square, times 4. So the volume, I'm just writing V for volume. The volume of C would be 3 times 3 is 9, times 4 is 36. Right, the volume of the whole shape, the final volume would be 120 plus 36, 156 centimetres cubed. And like I said at the start, you could arrive at that following some different methods. Okay? Now, I'm going to try and find the answer in the book. Yep, they've got it right. I just noticed with some of the answers, they're using approximately equals to. I think every time pi comes up, they're writing the answer as being approximate. So if you see this symbol in the answers at the back of the book, it means approximately equal to. As long as you're fairly close to the answer, then you almost certainly have done it right. Okay, so don't stress if you're 1 or 2 centimetres cubed different to the back of the book, especially for shapes like the next one I'm going to do, where pi is going to be involved. All right, so we've got a cone sitting on top half a sphere. All right, you probably do want to go look for the formula for a cone. All right, so volume of a cone is 1/3 times the area of the circle on the bottom of the cone. All right, so we find the area of this circle, pi r squared, and then we multiply it by 9, I forgot the height, times by 9, but you can see that this shape is tapering off to a point. Right? If it was a cylinder, I would just multiply by 9 and I'd be done. Right? But it turns out that we also need to divide by 3 or times by 1/3 to get the accurate volume of the cone. So that'd be a good one to look up, that formula, but it's not really too hard to remember, right? Because it's basically just a cylinder here. That's the volume of a cylinder times 1/3, right? And really, you should be memorizing the area of a circle at least, right? There's a circle on the bottom there. So the volume, 1/3 times pi times 5, our radius, squared, that's 25, times 9. All right, so maybe I could do a third of, what if I did a third of 9? That's 3. 1/3 times 9. The order that we times these numbers doesn't matter. Right, so a third of 9 is 3. We've got 25 there, times 25, well that's 75. So let's just write that. 3 25s are 75 times pi, 75 pi. Let's find out what that is. Is the calculator. I'll just get that out of the way first. 75 times pi, where's pi here, is 235.6. I think 1 decimal is enough for the meantime. 235.6. There we go. 235.6. All right, and that was the volume of the cone. In fact, we might actually just write it over here. 235.6. Okay. When it comes to the final answer, I'm actually going to get rid of that decimal. But as I'm working through the question, I like to maybe keep a few extra decimals, and really the rounding that I really need to think about is going to come right at the final part of the question, at the end of the question, okay? And like I said before, I think the book is going to give an approximate answer to this. So there, when we get to the volume of the final shape, they're going to do these squiggly, approximately equal to some cubic centimetres. All right, now we've got this half a sphere. All right, they've given us the radius. Be on the lookout for when they give you diameters and not radiuses. Right, the volume of an entire sphere and the surface area of a sphere and the area of a circle, they all use r, radius. Luckily, we've been given the radius, but you will not always be given the radius. I can see this little circle here, they've given a diameter, and you would have to half that. All right, so volume of a sphere equals 4 on 3 pi r cubed. Okay, so we've got 4 on 3 times pi times r cubed. So it's 5 times 5 times 5, 125. Right, but I would just put it all into a calculator in one go. So let's go and do that. 4 on 3 pi times 5 cubed. Let's clear the screen here. 4 on 3. Right. Now, when you have division, it's not necessary, but you may want to put those inside of brackets to be on the safe side. Times pi times 5 to the power of 3 equals 523. Let's use 1 decimal place again. So I want to go to that decimal place. Do I keep it as a 5 or do I round it up? I need to round up because the number after it is a 9. So there'll be 523.6. 523.6. Let's write that in. If I was in a classroom at this point, I'd say, is this right? Have I done it right? And the answer would be no, because we don't have a whole sphere. We've only got half a sphere here. So we still need to actually halve this number. All right? The volume of half a sphere. All right? That would be, let's write it over here, half of the sphere will be this number divided by 2. Right. So back to the calculator. Take your answer, divide it by 2. 261.8. 261.8. And now we simply need to add the two volumes together. So what do we end up with? We use the calculator just so I don't make a mistake while recording. So we want to add that number plus the cone is 235.6. 235.6. That equals 497. Now, I'm just going to round it to 1 unit here. I'm going to report this answer as approximately 497. Right. And the reason for that is because the original measurements they gave me were whole numbers. Right? They didn't say it was 9.00. In that case, I could have gone to 2 decimals in the answer. They just said 9. Right? And I mean, technically, that 9, maybe it lies in a range. If I was thinking about the accuracy of that 9, this is something you can actually talk about in your folio tasks, is the accuracy of the measurements that you've used in your sketch. That 9, as far as I know from that diagram, could really range between anything greater than 8.5, because that would round up to a 9, all the way to anything smaller than 9.5. In fact, if it was equal to 8.5, we'd still round it up. So greater than equal to 8.5 up to 9.5. And I don't want to start taking a measurement like that, using it in a whole lot of calculations, and then writing all these decimals. It's almost a bit dishonest. I'm saying I know the answer more accurately than I really do. So that it would make sense to leave this just as a whole number. And if you like, you could say it's approximately equal to that. Right? The book seems to be using this approximately equal to whenever we use pi, probably because pi is an irrational number, and they might be thinking that some people might be, instead of pressing the pi button, I would recommend you press the pi button on your calculator. Some people might be doing this, entering 3.14. All right, now it shouldn't say it equals because it doesn't equal that, but this is a good approximation. Or some people say it's approximately equal to 22 divided 7, right? And I don't actually mind if you use those values for pi. So like I was saying, if you're doing these volumes and surface areas, there's if you're within a couple of units of the answer, then chances are you're going to get full marks for that question, as long as you've shown you're working out. Okay? All right, thank you.